Swayam Prabha. Digital India. Educated India.
Welcome to the case study on regression. In this session, we are going to be taking the case study predicting price of pre-owned cars, and we are going to build a regression model on it. Just to give you the problem statement, Storm Motors is an e-commerce company which acts as mediators between parties who are interested in selling and buying pre-owned cars. So this is an e-platform for selling or second-hand cars. So what you have been given with is the data that was collected between the year 2015 to 2016, and they have recorded details about the seller and car. So whatever information that has been collected has been broadly bucketed into specification details about the car, the condition of the car, seller details, registration details, web advertisement details, make and model of the car, and price, which is in dollars. Now, Storm Motors, they wish to develop an algorithm that helps them predict the price of the cars based on the several inputs that they have collected. So let's see what these input variables are. You have date crawled, which is of the date data type. It's the date when the ad was first crawled on the website. It has no categories. It's a date data type. Then you have name, which is a string. It consists of the car name, brand, model, and other things. It's a string data type, and it has a combination of strings. Seller tells you the nature of seller. It's again a string. It tells you whether the seller is private or commercial. Offer type is whether the car is on offer or has the buyer requested for an offer. So offer type is an offer or request, again a string variable. Price is an integer here. It's the price that has been quoted in dollars. A/B test, this variable is a string again. So this variable basically has two categories. One is called test and the other is called control. And this basically tells you the two versions of the ad that has been floated. So vehicle type is a string, and it's the types of cars that you have, whether you have coupe, SUV, limousine, etc. So there are overall 8 categories in this variable. Now year of registration is an integer which tells you the year in which the car was first registered. Gearbox, a string, and it tells you the type of gearbox. There are two types of gearbox in this data. One is manual and the other is automatic. Power PS is an integer. It tells you the power of the car in horsepower. Model tells you the model type of the car. It's a string. The variable kilometer is an integer. It tells you the number of kilometers the car has traveled. Now month of registration is a qualitative integer. It tells you the month in which the car was registered. So the month is from 1 to 12. Now fuel type is a string. It tells you the type of fuel that is used in the car. You have petrol, you have diesel, you have CNG, and there are few more categories to this. Now brand tells you the make of the car. There are many categories to it. Now the variable not repaired damage is a string again. Now this variable basically tells you the status of repair for the damages that are already present in the car. Now if it is yes, then it means that damages which are there have not been repaired. But if the category is no, then it means that there were damages, but then they have been taken care of and they've been repaired. The next variable is date created, which again of the date data type. Now it is the date on which the ad at Storm Motors was created. The variable postal code is an integer. It gives you the postal code of the seller, and the variable last seen is a date data type. It tells you the date on which the ad was last seen by the crawler. So these are the variables in the data and their description. So now let's look at which of these variables go into which of these buckets. So under specification details, we have gearbox, power, and fuel type. So specification details is exactly the specification details which are given with the car. So under condition of the car, you have not repaired damage and kilometer. Both of these variables show you the wear and tear of the car. Seller details include seller and postal code. Registration details consists of year of registration and month of registration. So under make and model, you have brand, model, and vehicle type. And under advertisement details, you have date crawled, name, A/B test, date created, last seen, and offer type. So this is how you will group the variables into the given buckets. So let's move to Jupyter and see how to code the entire solution process. So first we are going to start with data preparation and exploratory data analysis. So let's first start by loading all the necessary packages. So there are two packages that we are using here. One is for visualization and one is to remove all the duplicated records in our data. So the first package is called ggplot2. Now to load any package, you need to use the function library, and within the parenthesis you can give the name of the package. So I'm using ggplot2 for data visualization. For removing all the duplicated records, we are going to be using the package dplyr. So once you execute these two commands, the package is loaded in the environment. Now to suppress all scientific notations, I'm using the function options. Now within parenthesis under the parameter scipen, you can set the number as 999. Now this basically suppresses all kinds of scientific notations. Now by scientific notations, I basically mean that whenever you have an output which is 0.99, for instance, let's just assume this. When I have the scientific notations turned on, that is by default, you basically get it as 9.9 e power minus 1. It's more easy to interpret it as 0.99 as opposed to 9.9 e power minus 1, right? So we are going to suppress all kinds of scientific notations in this. So once you execute it, all scientific notations are suppressed. So let's start by reading the CSV file. So to read a CSV file, you need to use the function read.csv. Now within parentheses, under single or double quotes, you can give the name of the file. So the name of the file for this case study is cars_sample.csv. Now within the parameter na.strings, you can basically give all blank cells to be read as na. To represent blank cells, you can just put them under double quotes or single quotes and just replace them with na. So na stands for not available. It's not applicable, it's basically not available. So these values are not available in the data, so I am representing all the cells which are empty as na. Now the reason we've chosen na and not any other value is because R provides a host of functions which allow you to deal with such kinds of values. So once you execute this function, a data frame of the name cars_data is created in the environment, and the number of rows and columns of this data frame can be obtained using the function dim. Now dim stands for dimension, and you need to give the name of the data frame within parenthesis. So once you execute it, you will get the number of rows and number of columns. The first output is for number of rows, the second output is for number of columns. Now before we move further, we would like to create a copy of it. Now the reason of creating a copy of this data frame is that, so whatever changes that we are going to make, it's going to be on the copy and not on the original data frame. So what we are going to do now is create a deep copy. So R by default gives you a deep copy. So by deep copy, what I basically mean is that any changes that I make to the copy data frame, those changes are not reflected in the original data frame. So your original data frame remains intact. So all you need to do for deep copy is just create a new data frame equated to the old, and once you execute this line, we have a cars data frame that's created with the same number of rows and columns in the environment. So now let's look at the structure of the data set. So to know the structure of the data set, you need to use the function str and give the name of the data frame. Like I earlier said, I'm going to be using only the copy data frame as an input here. The reason of understanding the structure is to basically know what are the kind of variables you have. Now what you see here is basically the data frame. So it tells you that cars is a data frame with 50,001 observation and 19 variables. And on the extreme left, you see the name of all the variables. So the middle row is to tell you the data type, and on the extreme left, you see some of the values. So the data type factor is used to represent the data type of a categorical variable. It's a string data type, and just next to it, you'll also see how many categories are there. Now these categories are represented with the word levels. So whenever I say I have 12,039 levels, it basically means that I have 12,039 categories. Variables which are of the date data type, like date crawled, date created and last seen, all of them have been read as factors. They should ideally be read as date data type, but they've been read as factors here. So variables like seller and offer type have to be read as categorical variables, and you'll see the corresponding number of categories in each of these columns. So now that we know a gist of all these variable and their data type, let's go ahead and understand the summary of the data. Now the function summary of this data frame gives you a 5-point summary for a numerical data, and it gives you the frequency distribution under a categorical data. Since date created, date crawled and last seen, all the three of them have been read as categorical variable. You will see their corresponding frequencies being listed here. For numerical variables, what you will basically see is the minimum and the maximum value, the first, second and the third quartile value and the mean value. So for numerical variables, you see a 5-point summary, and for categorical variable, you will see that it gives you a frequency or a count under each of the categories. So under some of these variables, you will notice that NA is also one of these categories. So this is a gist of all the data set. Not all of the columns have missing values, but some of them do. Now that we have a fair idea of how does the structure and the summary look like, we would also like to identify variables that are not of any use to us. Not that they are not going to be of any use to us, but they are not going to be useful in answering the questions or the objective that we have posed earlier. So I am going to start by identifying those variables. So in this case study, we are going to let go of the variables name, date crawled, date created, postal code and last seen. The reason of dropping these columns are because they are not useful in helping us achieve the objective that we have earlier set. Now let's say if you are planning to do a more spatially based kind of an analysis, and then in that case you can use postal code and then get the countries out of it. For this case study, for this and the upcoming sessions, we are going to be building a generic model that is independent of the location. So that is what we are going to do. This is the first step of model building process. So we are going to be dropping these columns. So to drop these columns, I just need to give the name of the column in single or double quotes within the function C. The function C, as you all know, concatenates the different values that has been given to it, and all these column names I am going to be saving it under the variable call. Now call consists of all the column names that I want to drop. So these are the 5 columns that we are going to drop. Now to drop the columns, we are going to be using the following expression. So we are going to be making changes in the copied data frame. So I'm going to overwrite the existing data frame with the new set of changes. So all the columns that are being dropped are from cars, and I'm saving it back with the name cars so that all the changes get reflected in the copied data frame. So that is the purpose of overwriting it. So to make any of these changes, you need to make it in the cars data frame. So I'm giving cars, and within square index, I'm just giving the condition here. Now this condition is on the columns. I am not removing any of the rows here. I am going to keep the place before the comma, that is for the rows, empty, and all this condition is on the column. So this condition goes after the comma for the columns. So names of cars gives us the column name. So when I add an exclamation ahead, it means I want to drop certain column names. So drop the columns from cars which are present in the variable call. Now we know here that call consists of the variables that we already want to drop. So that is a set of all string values. Now names of cars also return string values because it returns the column names. Now let's take an instance here. So let's take the first variable in our data, which is date crawled. Cars gives you column names in that order in which they are found in the data frame. So the first variable is date crawled. It will check for date crawled from the cars data frame, and if that column name is present in call, it will basically drop it from the original data frame, which is cars. Now let's take the variable seller, which is another column name. Now names of cars, let's say if it's seller, in that case it's not present in call, so that gets retained. So this is how this expression basically boils down to, and once you execute it, the existing cars data frame gets overwritten and all the changes are made to the copied data frame. So let's find out the new dimension of this cars data frame. Once you use the dimension function, you will see that we have the same number of rows, which is 50,001. However, on the columns we have 5 down. So we started with 19 earlier and now we are at 14. So we know that these are the 5 variables that we want to drop, and now that they have been dropped, you will see that the reduced number of columns is 14. So now that we have removed all unwanted columns, the next step to it is to remove all duplicated records. Now to remove duplicated records, you need to use the library dplyr, which we have already loaded on the environment, and the function that you need to use is duplicated, which will basically identify the duplicated records. Now this condition is on the rows, so you can see that in the existing cars data frame, I am putting this condition on the rows. The columns remain intact. I just want to remove rows which have been duplicated, but there are no condition on the columns. Duplicated of cars basically returns all the duplicated records. So when I add an exclamation in front of the function duplicated, It basically means that remove all the rows which have been duplicated from the data frame cars. And once I execute this function, you will see that I am overwriting it in the existing data frame, and the new dimension of the data frame is 49,531. The number of columns are intact, but you see that there is a dip in the number of rows that you have. So we've let go of 470 records. So you will see that the number of rows is 49,531, whereas the columns remain intact. The number of rows have dipped from 50,001 to 49,531. So there are 470 duplicated records in our data which have been removed. In this lecture, we looked at the problem statement and the variable description. So here we know that data exploration and exploratory data analysis are going to go in tandem. We are going to be using some of the techniques to identify attributes which influence price. And then we started by reading the data, and then we looked at the structure and the summary. The structure gives you an insight on the data types for all the variables given in the data, whereas in summary you get a 5-number summary for numerical variable and the corresponding frequency or counts for categorical variables. So what we also did was we removed variables which are not helpful in answering our objective, and we also removed some of the duplicated records. Thank you.